I'm gonna stand back a little bit and increase the power. I'm hoping that at least the capacitors are not charged anymore. Let's try them out. Okay, let me show you how well it works. First, without the anti-pair. The skin here is quite sensitive to temperature and you can tell the temperature quite accurately. It's almost finished now. Just need another piece of wire. Oh sh**. What did I do?
What the f*** did you do?
I'm fine, thanks.
Idiot.
What? I can't even play music from it. And you can see a tiny negative sign beside it. That means that that side needs to be connected to ground or negative. The first thing you need to do is to remove the broken ball. Just make sure you don't cut your fingers and take the screw part out. My finger. Good thing the breaker opened. Now it's time to put the new bulb in. Just screw it nice and tight and it'll turn on. It's not turning on. I broke the ball. Well, the lamp is already out, so always use a tool to get the screw part out. Unplug! Damn it! Unplug! Let me show you what I mean by this oscillation. If I put the bullet inside the coil and try to turn it on with my power supply here. Well, it's always safer not to work with live loose wire, so instead I'm using these alligator clips here. I put the bullet in and turn the power supply on so you can see what's going on. There you go, you saw what happened. Oh, shit. This power supply can generate 20 volts, 150. Well, you see when I short it, the voltage goes almost to. Although this power supply can generate huge amounts of current, it can't send it through my body because it's only set to 20 volts. I can't even feel it on my fingers. I like to put it on my tongue, but before that I have to reduce the voltage to something like 1 volt because you know the resistance of the tongue is much smaller than the skin. And still if I short the power supply I get the same 150 amps. Okay, you can see it still sparks. Let's try it out. What the f***? I thought I set it to 1 volt. Here's the power supply at 4 volts and I'm going to connect this thin wire to it and you can see how the wire melts and burns under. Makes you want to join the dark side. Get it? It's a line from Star Trek. Okay, now let's. Always be aware of your surroundings. The tip of the gun here simulates a human finger. Always be careful with your tools. Because now the board is charged to the same level as the gun and it doesn't jump anymore. But right now I'm touching the wires and I can't even feel it because the voltage is not high enough. Who's this? No, I'm not Steve. Wrong number. It's a simple device. It's a belt that you tie around your belly with a tiny device that senses your motion. As long as you move, you're okay. But if you stop for any reason, it'll zap you like a mother. You will move no matter what, or else you will feel the pain. The device may often false trigger. The belt is very hard to open. It's made of very durable material resistant to sharp objects and it cannot be cut. So you will run until the batteries die or you die. Just kidding, we have never had failed batteries. The device is very simple. It runs on 2 AA or AAA batteries and has 2 electrodes on the bottom and turns on with a switch. Now if you don't move, it says unless I do it with my finger. With this revolutionary device, with the flick of a switch, you're ready to But the first thing to remember is that there are a lot of bits and pieces and small and large screws that go in the camera. So always remember what goes where and store them nicely to avoid losing them. Now let's take a look at the camera here. And you can see the lens here, and if I remove the lens, you'll see the giant flash capacitor back here. Ow! Piece of shit! Apparently the flash capacitor is holding around 300 volts of charge in it, and it can hurt a lot if you touch it. Try to turn it on and retrieve all the data. Hi, I like to create those Lichtenberger figures. They are made by placing very high voltage across wood and burning traces in it with electricity. So I need to make very high voltage. This can be potentially done by the transformers commonly found at home. There are these old style wall adapters that contain a transformer. But these things nowadays are being replaced by the much more efficient switching mode wall adapters. So time is short. For the price of a lifetime of inefficiency and shame, you can get your own. But wait, I'll throw in a second one if you promise to jump off a bridge. We need to learn to use energy more efficiently, and this is not one of them. But every technology starts from somewhere. This kind of wall adapter starts with a transformer that reduces the AC voltage. And then there is the full bridge rectifier that generates a DC output. Sometimes they also add a voltage regulator at the end to make the output level more stable. Measuring the AC voltages at the input. Make sure not to short high voltage with your probes. Now at the input we get around 120 volt AC as we expect, and at the output we have 7.6 or close to 8 volt AC. This means that the primary to secondary number of turn ratio is around 15. And you know what it means? If I flip the connections of primary and secondary, instead of 15 times reduction, I'll get 15 times more voltage, around 1800 volt AC. Let's do it. I cut the rectifier circuit from the output and soldered the power cable to the secondary. But let me remind you, if 120 volt AC can potentially kill you, 1800 volt AC will definitely kill you, and since you won't have time to turn it off, it will kill every single family member that comes to your rescue. And your negligence causing manslaughter will land you in the deepest pit in hell, where they have Kanye West's cover of Queen's Bohemian Rhapsody on repeat.
I just killed a man.
That's horrible. So don't do this at home. Now we'll have high voltage as what the hell? Did I short something? Okay, retry. So don't do this at home. Now as soon as I turn on this, what the f? What is this? Ow! One of these days. Maybe the transformer is broken. Let's get another one. This kind of wall adapter starts with a transformer that reduces the AC voltage. Don't try this at home. Now as soon as why? What's going on? Why can't I flip the sides? Might have something to do with the inductance. I have to measure the inductance now. I have to get an LCR meter. Stay tuned, I'll get back to you. Hey, I'm back. I got an LCR meter from Circuit Specialist as usual, and this thing is around $60 and pretty much does everything. It measures not only inductance, capacitance and resistance, but also AC and DC voltage and current, diode, HFE of transistor, frequency up to 10 MHz, and even comes with a thermocouple to measure temperature. I checked its functionalities and all work well so far. I'll leave a link in my video description if you need one. Also, I think it makes a good gift, so I'll give away 10 of these to my viewers and patrons at the end. Okay, let's measure the inductance. The primary is around 1.35 Henry, which is nice and large, but the secondary is around 6.4 millihenry. So the impedance of the secondary is around 2.4 ohms only, which means at 120 volt AC we get 50 amps of current. 50 amp is huge. No wonder these keep arcing and blowing off. So I can't use these on the 60 Hz 120 volt AC city power. But I'm pretty sure if I increase the frequency and lower the voltage, limiting the current, I should be able to use them. Let's try it. I'm giving a 1 kHz 1 volt amplitude signal to the secondary of the transformer, which is now our primary. And at the output, I'm reading 15 volts amplitude. See, I'm not totally crazy. Just that for high voltage 60 Hz, we need a different transformer. Which I have one. I scavenged from a microwave oven in my other video. Now the inductance of the primary is around 37 millihenry. That means at 60 Hz I'll have around 14 ohms of impedance, and at 120 volt AC it means 8 amps of current into primary. Still not very small, but I guess it's not large enough to trip a breaker. So let's power it up. But this outputs around 2000 volts, and with so much power available, this is definitely a killer. Tell me! Like your magnificent smile. Oh, that's cute! That's nice. I've never heard something. Averted. Okay. Oh, no explosions. Now if we measure the current into the primary, you'll see it's around 7.5 amps, even with no load. Now you might think that power is voltage times current, so 7 amps times 120 volts is 840 watts of wasted energy, but that's not correct. Unlike resistors that voltage and current are in phase, an ideal inductor causes 90 degrees current phase shift. If you look in this area, voltage and current are both same direction like a resistor, which means the inductor is pulling energy from the power line. But then here, the direction of current and voltage is opposite. It means the inductor has turned into a generator and is putting energy back into the power line. This push and pull of power results in a net zero power consumption in an ideal inductor. But then again, the power lines or the primary of the inductor have some inherent resistance, as well as the core of the transformer humming like crazy. All these waste power, somewhere around a couple of watts. So in general, it's not a good idea to keep these plugged in. Now let me measure the output of the transformer. I'm using a resistor divider to step down the voltage first to protect my multimeter. Now if we measure that, it is... Make sure the resistors you pick are rated for the power you will put across them. Forget about the resistor divider. Let's use this variac or variable transformer from Circuit Specialists. It will reduce my voltage so I can safely measure it. Okay. I set the input to 10 volt and the output is 200 volt AC. This means that the transformer number of turn ratio is around 20. So at 120 volt AC input, I'll have around 2400 volt AC output. I say that's pretty good to make Lichtenberg figures. So here's what we need. A piece of wood, put 2 nails in it, wet the surface with a mixture of water and baking soda to make it conductive. Connect the output of the transformer to the nails. Maybe put it on a piece of glass so you won't burn your table. Okay, let's slowly raise the voltage and see what happens. Yeah, there is something. Oh! This is not water and baking soda, it is lighter fuel. Always read the labels. In any case, this looks like a dangerous experiment to be done indoors. Let's go into the kitchen. Okay, let's make some Lichtenberg. choice of wood was poor. Seems like it's going mostly on the inner layers. A masterpiece, isn't it? One more try. More liquid.
Yeah.
Whoa. I probably should stop this. Thank you, Breaker. I think the problem is I'm not an artist. At least a bit of it looks nice.
Giveaway time.
Thanks to circuit specialists, I can give away 10 of these meters, 2 to any one of you viewers and 8 to my patrons at patreon.com. My patrons automatically enter the draw, but for the viewers, I think you have to leave a comment under the video so I can select 2 at random. You better start it with a special sentence so I know you need the meter. Something like, give me the meter! And don't forget to share and like the video. And while you're at it, dare I say, you might want to support my channel and become a patron.